Kepler-22b, a world 600 light-years away, orbiting a star much like our Sun, and yet unlike anything we've ever seen. For decades, Kepler-22b has fascinated astronomers, astrobiologists, and science enthusiasts around the world. Confirmed as the first exoplanet firmly located in the habitable zone of a Sun-like star, this mysterious world has inspired countless hypotheses about alien ecosystems, atmospheric chemistry, and the possibility of complex life. But what would Kepler-22b actually look like? Could it truly host oceans, forests, or even advanced biospheres? And what would a rainforest world, shaped by alien evolution, really be like? In today's documentary, we reveal the science, the speculation, and the cutting-edge models that bring Kepler-22b to life. Welcome to Kepler-22b Revealed, the alien rainforest world. The story begins with NASA's Kepler Space Telescope, launched in 2009. Its mission was simple: find planets that pass in front of their stars, tiny dips in brightness known as transits. And on December 5, 2011, NASA confirmed a monumental discovery: Kepler-22b, the first known transiting planet in the habitable zone of a Sun-like star. Let's break down what made this discovery so important. The transit method. Kepler detected Kepler-22b by measuring incredibly small dips in starlight every 289.9 days. This told us the planet orbits its star once per Earth year. It's close enough to potentially support liquid water. The planet is 2.4 times the radius of Earth. It may be a super-Earth or a mini Neptune. At the time, we didn't know if it had a solid surface or a thick gaseous envelope, but scientists quickly realized Kepler-22b sits at the perfect distance for Earth-like temperatures. This triggered a wave of interest and speculation. To understand the potential for life, we need to break down the world's temperature, atmosphere, ocean and land distribution, chemical composition, stellar radiation environment. Temperature estimates. Kepler-22b orbits its star at 0.85 AU, slightly closer than Earth does to the Sun, but its star is slightly cooler. This evens out, giving the planet an estimated surface temperature of 22 degrees Celsius or 72 degrees Fahrenheit average, assuming Earth-like atmosphere. That's room temperature, perfect for liquid water. Atmosphere possibilities. Scientists hypothesized two main models. Model A, Earth-like atmosphere. Nitrogen plus oxygen. Thin greenhouse effect. Potential for photosynthesis-like chemistry. Stable weather patterns. This model creates rainforest-capable environments. Model B, thick super-Earth atmosphere. Higher pressure, heavy clouds, stronger greenhouse effect, more humid, warmer surface. This could result in a planet-wide tropical environment with constant fog, rain, and lush biomass. Ocean distribution. Kepler-22b may be 90% ocean, 10% archipelago landmasses, or a high-scene world, mostly deep global ocean with floating forests or microbial layers. But the most intriguing scenario, supported by climate simulations, is a humid, warm, rainforest world with global cloud cover. a perfect cradle for alien life.
Let's explore why many researchers think Kepler-22b could resemble a global rainforest. 1. Size and gravity. At 2.4 Earth radii, its gravity may be about 1.2 to 1.3 g, slightly stronger than Earth's, enough to support dense vegetation, huge root systems, towering megaflora adapted to higher weight. 2. Temperature and humidity. If oceans evaporate more easily under a warmer atmosphere, you get powerful water cycles, constant rainfall, enormous humidity, and cloud forests across the entire planet. Rainforests thrive in exactly these conditions. 3. Photosynthetic energy. Kepler-22b's star emits slightly different wavelengths. Plants might evolve blue-green reflective leaves, bioluminescent pigments, higher efficiency light harvesting structures. Alien plants may look nothing like plants on Earth. 4. Atmospheric density. A thicker atmosphere means slower falling raindrops, floating spores, flying creatures supported more easily, massive airborne vegetation networks. So, scientifically, a planet-wide rainforest is completely possible. Now, we build a scientifically grounded vision of what Kepler-22b might look like. Alien flora. Instead of trees as we know them, imagine spiral towers that maximize sunlight absorption, canopies hundreds of meters wide, vines that grow horizontally across the sky due to dense humidity, leaf structures that glow faintly at night, massive root networks that communicate chemically. These life forms evolve to efficiently capture scarce photons and survive perpetual rainfall. Bioluminescent vegetation. Frequent cloud cover means less sunlight. Plants may compensate by developing internal light channels, bioluminescent pigments, reflective mirror-like membranes. At night, the rainforest may glow green, blue, or violet. Water everywhere. Expect constant rainfall, massive rivers, warm shallow seas, fog-filled valleys, floating vegetation rafts. In many simulations, Kepler-22b is a water-rich paradise with ecosystems stacked vertically. To remain scientifically grounded, let's examine the likely building blocks of life. Carbon-based life. The most probable because carbon forms long, stable chains. Kepler-22b sits in the right temperature zone, and liquid water likely exists. Alternative biochemistries. The rainforest world may support purple photosynthesizers using bacteriodopsin, silicon-carbon hybrids if volcanic silicon is plentiful, floating microbial mats forming kilometer-wide networks, but the dominant life will almost certainly be oxygen-producing autotrophs, complex heterotrophs, ecosystem engineers, and insect-like flyers adapted to thick air. Rainforests create complex food webs. Kepler-22b's thick atmosphere and strong gravity will shape unique creatures. 1. High gravity adaptations. Creatures will be lower to the ground, broad and muscular, built for stability. Tall, thin animals are unlikely. 2. Air density benefits. Thicker atmosphere means massive flying organisms are possible. Balloon-like floaters may exist. Winged creatures expend less energy. Imagine jellyfish-like flyers drifting through the trees. 3. Senses and communication. In constant humidity and dim light, life might use echolocation, chemical communication, bioluminescent signals, electromagnetic sensitivity. A rainforest world favors sophisticated communication networks.
The big question: could an advanced civilization evolve here? Let's break it down scientifically. Environmental pressures. A rainforest world encourages cooperation, navigation skills, tool use, social behaviors, territorial awareness. These are key ingredients for intelligence. Possible intelligent species. If an intelligent species evolved here, it may be arboreal, tree-dwelling, skilled at communication in darkness, using chemical or bioluminescent languages, highly social due to dense ecosystems, physically compact due to gravity, nothing like humans, but equally capable of complex thought. Neurobiological potential. High oxygen rainforests can support large brains, complex neural networks, energy-intensive cognition. So yes, Kepler-22b could produce intelligence under the right conditions.
Kepler-22b likely experiences permanent cloud cover. A global rainforest keeps the sky filled with thick clouds, perpetual mist, frequent lightning, warm rainfall. Hyperstorms. Large atmospheric cells may create planet-wide hurricanes, 10-day thunderstorms, jet stream-shaped storm belts. These storms may drive evolution dramatically. Modern telescopes help us probe Kepler-22b from afar. The James Webb Space Telescope could detect its atmosphere. What could we find? Oxygen, methane, water vapor, carbon dioxide. Imbalances that suggest life. The most exciting possibility? The vegetation red edge. Plants on Earth reflect infrared light. If Kepler-22b has vegetation, JWST could detect a similar signature, or a completely alien one. This would be the first scientific evidence of an extraterrestrial biosphere. Kepler-22b represents the first true Earth-like exoplanet found, a template for habitable super-Earths, a potential biosphere different from Earth, a case study for alien evolution, a testing ground for new atmospheric models, a key target for future interstellar missions. If life exists there, even microbial, it changes everything. Kepler-22b remains one of the most exciting worlds ever discovered. Not because it's identical to Earth, but because it might reveal how life evolves on worlds that are almost Earth, but not quite. A lush rainforest world, wrapped in clouds, filled with alien chemistry, teeming with life forms shaped by a completely different evolutionary timeline. Kepler-22b challenges our imagination and our science. If humanity ever reaches it, we won't just be exploring another planet, we will be entering an entire alien biosphere. Thank you for watching Kepler-22b Revealed, the Alien Rainforest World. Be sure to like, subscribe, and comment what other exoplanets or alien ecosystems you want us to explore next.